Morning, folks, and Happy New Year. This video begins 3.4, where we talk about conservative and non-conservative forces. The goal of this video is to understand the difference between the two and beginning to recognize when one or the other is acting. So we first define a conservative force. A force is conservative if it can cause energy transformations within the category of mechanical energy. That's a good definition. Probably a better definition is if the force is associated with a type of potential energy that we're studying, then it's a conservative force. Conservative forces are capable of storing energy, and so they have to be associated with some form of potential energy. So we're going to look at this ball that's like rolling along these hills, goes up a hill and down a hill, and then we'll like categorize some conservative force patterns. From A to B, we can say that gravity does negative work. Okay, why does that happen? Well, the ball moves up and gravity acts down. And so gravity will overall do negative work. The result is the kinetic energy will go down, right? So negative work done by the net force is going to reduce the amount of kinetic energy, but the gravitational potential energy has gone up because now this object is at a greater height. And overall, the change in mechanical energy is zero. So basically what gravity has done is it has taken, has done work on the system, and that work has gone into storage, essentially. So that energy that gravity took out of the ball is now part of the system of the ball and the earth, and so gravity is now storing that force, that energy, and that energy can then be released. So this gravity does negative work. If you take more physics courses, this becomes more relevant. This negative work by a conservative force always results in a positive change in potential energy. We don't really get into that here, but it just happens. On the way down the hill from B to C, gravity does positive work. Same idea, but now it's the opposite. So we have a positive change in kinetic energy. So positive work on the ball is going to increase its kinetic energy. The gravitational potential energy goes down. So that energy that was stored by gravity is now released. And then overall, the change in mechanical energy is zero. So because gravity is the only force doing work in this situation, the mechanical energy is not going to change. And so what you're looking for is situations where only conservative forces do work. The conservative forces that we study are gravity and springs. They are associated with gravitational potential energy and elastic potential energy. So when those forces do work, and only those forces do work, we have a conservation of energy situation where the mechanical energy is constant. Okay, second example is for non-conservative forces. A force is non-conservative if it causes energy transformations between mechanical and non-mechanical energies. Now, non-mechanical energies, heat is a big one, light, sound, and etc. But heat is really the big one. When you think about friction, or you think about like the process of like eating food and then exercising, those things generate heat, and so that's where we lose energy. And so this example is going to deal with a couple sources of that. So we have our friend here. This is not a boulder, this is just a block. Our friend Sisyphus here pushing the block up the hill and then sending the block down this rough patch where it gets down to the bottom. Now I'm going to imagine some very specific things here, but very obviously this person here is pushing up the hill and the block is moving up the hill. So the person does positive work. Now, if they push really hard, they increase the kinetic energy. If they don't push very hard, then in theory, the block could slow down. I'm going to imagine a situation where the person pushes the block up at a constant speed. The only thing that happens, therefore, is that the gravitational potential energy of this system is going to increase. So the person is putting energy into the block Earth system, and the block Earth system's energy, potential energy, is going to increase. However, the change in kinetic energy is going to be zero because they're moving it at a constant speed. So there is a positive change in mechanical energy. So because the person is doing work in the same direction as the block is moving up the hill, there's an increase in gravitational potential energy due to that positive amount of work. And so there's an increase in mechanical energy. So we wouldn't be able to apply conservation of energy because the person is adding energy to the system. On the way down, the block is just going to slide down this rough surface. And so we can say negative work done by friction. Now I'm going to add a phrase in here that you're going to see a lot in AP questions. Friction does something very specific. It dissipates energy in the form of heat. Dissipate means to just like spread out in every direction. So if you like spray perfume in a room, it diffuses, but it also dissipates in every direction. This energy just like goes in every direction, and it doesn't disappear; it just like goes into other parts of the environment you're in. So there's negative work by friction. On the other hand, there's positive work by gravity. So we have a more complicated situation. We have a non-conservative force, that's friction, that dissipates the energy, but we have a conservative force by gravity. That positive work by gravity results in a loss of gravitational potential energy and a potential gain in kinetic energy. Maybe. You will be asked about this situation probably on the AP exam. The kinetic energy could increase, it could decrease, it could actually stay the same. We're going to, for this one, assume that it does gain some kinetic energy. However, we have a negative change in mechanical energy. So there is loss of mechanical energy due to friction. So even though gravity appears to be like conserving energy by taking the potential energy and making it kinetic, there's an overall loss of energy because of that friction force. So I wanted to present that idea because we just talked about gravity being a conservative force, but it only works if it's the only force or if there's gravity and springs. So if the forces doing work are exclusively these two, then you have no change in mechanical energy. If you have any other source of force doing work, then you don't have constant mechanical energy. So to make a kind of silly list of non-conservative forces, friction is at the top. People and machines are up there as well. So those are things that can put in or take out energy. Collisions dissipate energy. We'll learn about collisions in the next unit. Any sort of fuel is a source of chemical energy, and so that can be released and change the mechanical energy of a system. There's more things that would go on that list, but just look out for things that are not gravity and springs doing work, and that is an example of non-conservative work.